Yeah, so okay, I made an audio, but that audio may not be too clear to what we want to discuss. So I want to make this short video so that you understand what I'm saying. So look at this breaker. That is the same breaker I just sent to you. This breaker is here. Is a shunt. That is the company that produces it. This N, look at this. This is a NMS8 630H. Okay, this H has to do with the tripping, high trip, short trip, and low trip. This 630 is the current. Okay, this one is the series it belongs to. Okay, this IN is the rated current. This is the what continuous working current, the current that this breaker will have. Okay, let's look at the breaker. I say the IN is the 630 amps. That is the continuous current that this breaker will carry any day, anytime, that was not without any problem. Okay, then that is, or you call it the rated current for the breaker. Or look at the UE. The UE is the rated voltage. Okay, the maximum voltage for this breaker without any problem. It will carry it without any problem. Okay, it's continuous voltage that can pass through. There will not be any issue. Then UI is 750 volt. That is the insulation voltage. The body of this breaker has an insulation capacity. Is an insulator. So at 750 volt, it will be compromised. So do not allow 750 more than 750 volt pass through this breaker continuously. It will damage the insulation. The frequency is 50 to 60 hertz. Okay, that 50 or 60 to function. Then we have UIMP. UIMP is 8 kilovolt. That is the impulse voltage. That is the voltage, the laboratory test voltage. An impulse voltage was injected into this breaker and it survived up to 8 kilovolt. It's a strong breaker. Okay, that is impulse voltage, laboratory test voltage. Now let's look at Cat A. Cat A is for breakers that does not have internal time mechanism to hold a fault and trip it later. You see, or else there is an external relay attached to them to help them do that. Okay, so in this case, this man has external relay. You can see this external relay. If you look at this, if you look down, please, I want the way the picture is clear. Okay, okay. Now look at the picture. Now you see this the whole. Follow my pink cursor. Look at here. We have LSIG. L means long, S means short, I means instantaneous. Then we have G. G means ground, N means neutral. Okay. Now look at these deep switches here. Look at the switches here. You can see that we have IR is equals to XN. X is the setting you do here. If you push these switches all up, push them all up. Remember, this is a relay to help the breaker to trip. Okay, and also when the fault comes in, the time setting we hold until that time is reached. If the fault is still there, it will now open the line. It will trip and save everybody from problem. With this man is externally added to this breaker. If it has an inbuilt timing delay, it will be cat B. It will be cat B. It will not be cat A. Okay. Now I'm going back to this relay. Now watch here. This is L. This is L. Okay. This is where our short. This will be our instantaneous. Okay, this is our long, short. You can see this is time for long, time for short, but there is no time here because it is instantaneous. Immediately you see just 3. So now L means long, S means short, I means instantaneous, G ground, N neutral. Okay, let's look at it. Look at these switches. All of them are up. See, all are up. If all are up, what do we have? We have 4. Look at it, 4. That means our X is 4. Sorry, is 0.4. Our X is 0.4. See, if all are up and 1 is down, 0.5. If first one up, second one down, third one up, 0.6. You can see the way it's going. So it becomes but what we have here is all up. That is 0.4. So 0.4 times IN. IN is that our 630 amps, which we saw here. Look at it, 630 amps. is also here. Look at it here, 630 amps. So if you multiply it, you will get the long short current. Okay, let's continue. I got some office distraction, so let's continue. Sorry guys. Okay, here, like I was saying, the IN for the long, this is the long, the L, this is the L, the long, so that is XN. So I told you that the X is the value you got from here. So if this is all up, that is 4.4 times 630, that is 252 amps. That is, so if you see, then the time is all down, that is 18 seconds. So if you see a fault of 525 ampere, which is even not a fault because the current flowing through the breaker is more than this. So this setting, this is not commissioned. So this setting is not commissioned. So normally the current in the long should be more than the rating of the breaker. You understand? Because this 630 is more than, so what we are expecting is so now, but in terms of fault, okay, if you have a fault can be of any value. Probably somebody dropped a spanner across face to face or face to neutral. So if you see the breaker will pick up 252 by this setting, and the time is 18 seconds. Or you can see the switch is all down 18 seconds. After 18 seconds, the fault is stay there to trip. Okay, let's look at the short. Remember that this peak is coming from the neutral. This current is the current from the neutral, not from the main the conductor. So that is why you see that the current, the long fault current is smaller than the flowing current, because the flowing current passes through the three phases, while this fault current passes through the neutral. So it is neutral we are dealing with here, because when there is fault, current flow to the neutral. Okay, so make sure you don't forget that. Okay, look at short. Okay, if you go up, all up is off, not useful, but here is all down. So that is 8, right? So 8 times 630, that is 40 amps. So that is the long. So now the time for the short circuit current is all up. All up is what? 0.1 second. So because the fault is so the time should be short. The higher the fault, the lesser the time. The lesser the fault, higher the time. Okay, then this one here is instantaneous, instanta, this is ISD, short, this is instantaneous. So that's why you did, there's no time in here. As you see, you trip, no time. Okay, this one is always high. You can see that it's always high. So, but here, let's see what they said here. They put up, down. Up, down is 2. It's wrong. It cannot be 2. Okay, cannot, because of this 630. Cannot be. In fact, this one must be higher than the long. Long is 550 40. Short must be higher than that. So short will be around, will start from maybe either 10 or 12. Either 10 or 12. It can be equal to, it cannot be equal to long. If you put 8, it becomes equal to long. So it should be higher than what? Higher than the short, higher than the long. So this is instantaneous. So it should be around 10. So you now have 6,300. You understand now? So that is it. So this is ground. This is ground. Okay, ground fault. We have down. Down is 1. So 1 times IN is what? 630. So if you have 630 in ground as a ground fault from your ground CT circuit your current transformer, okay, it will trip. And what is the time? So the time is down. All down is 0.4. So it will stay for 0.4 seconds and it will trip. I hope you understand this. So look at this. This point, this pin you see here is for program, or for you want to collect data after tripping. So this is a test point. If you want to test the breaker whether it is tripping well, press this system or test. If you press it in, it will trip. Okay, this is current rating. I hope you all understand this. Okay, here is customer data. This is customer data. Okay, the voltage the customer has required is 400 volts, but it can go up to 690. That's what it means, just like what you saw here. Then the short circuit current is 100 kilo amps. Okay, at 400. The ultimate short circuit current, ICU is ultimate, ICS is short circuit current. They are always equal at all times. So for 400 it's 100 kiloamps. For 690 is 20 kiloamps. So that is the current that when you drop when you bridge the two faces of the line, this is the current that is expected to be there. And at this current, the breaker will trip. Okay, I hope it's well understood. If you have any question, then you can ask. This for this very description, I will send you a data. I will send you this document so that you will use it to understand how to read it. Okay, then look at that. H means higher type current limiting technology utilized. S is standard. R is what? Current limiting type. Okay, so I will send you this page, this first page, so you will understand how to read the tag. Okay, so thank you very much. God bless everybody.